We're working on applying machine learning to do noise suppression of sounds like keyboard clicks or traffic noise or crowd noise, other kinds of noise that's really difficult to get rid of with techniques that don't use machine learning. And we've been pretty successful there. The challenge there is to come up with software that does machine learning that's very low compute that you can put on a product, on a speakerphone, etc. That'll kind of greatly enhance the audio quality in rooms where this kind of noise is a problem, which is especially open office environments. This will be very useful. Machine learning is inherently nonlinear. It does things that you can't model with math. Real life noise, real life speech, etc. You can't simplify it to a bunch of mathematical equations. It's just too complicated, and we can't even understand it, with the human mind. But the machine can understand it with training, because it's got all the compute in it that you can't model mathematically. So it can do like very complicated things you could just never do with math. With this machine learned audio noise suppression algorithm, it'll eliminate any kind of it'll try to eliminate any kind of noise that you give it. So it could be noise from people talking in the adjacent cube. It could be noise from a particular piece of machinery. It could be noise that's particular to the customer's environment. And potentially, if the customer gave us this noise data, which they could just record by having an open mic there and just recording noise for a day or so, then we could input our noise into the machine learning algorithm and teach it to reject that noise. And so we could custom tune the noise suppression specifically for the customer environment. So I've been in the audio business for about 25 years working on speakerphones, and the complaint that kept recurring over and over again is people complain about keyboard noise and other noises found in open office environments. So for the last 25 years, I've been working on ways to try to kind of reject that noise. And the best we could come up with classical techniques was noise block, and that was developed after 7 or 8 years of work. But noise block had the limitation that it basically just muted and unmuted the mic. So it would mute the mic if no one was speaking. It would unmute the mic if people were speaking. But it didn't get rid of noise while the person was speaking. Just unmuted the mic. And but with this new machine learning stuff, it actually gets rid of the noise all the time, whether you're speaking or not speaking. That's something we could never do. No one's ever done with the old technique. And this revolution is really remarkable because with machine learning, we can really solve many problems that I've worked decades on and been unable to solve. We can build better echo cancelers for sure with machine learning. We haven't done that yet, but just any kind of audio processing could probably be greatly improved with machine learning. Of course, our goal in the audio work on the speakerphones and anything is to make the audio, of course, as intelligible and as easy to understand without fatigue as possible. We wanted you to sit in a video or audio conference for 1 hour and not feel tired at the end from trying to understand the other person. And you don't need a tremendous quality to understand. If you think of a cell phone quality, people use cell phones, they can understand the other end, but it takes a lot of effort. We want to be way beyond that. We want you to be able to understand the other person with no effort, so you don't get tired in these long calls. And we think that's important to people working at a distance. If they're not stressed at the end of a call by straining to understand the other person, if they can just be completely relaxed, that improves the productivity. It makes working with remote workers just much easier.